union and union all operators, set operations. So merging tables, merging tables. So we call these are set operations, set operations in Hive. So in RDBMS we have two operations, union and union all. So we can take two sets, set 1 1 2 3 4, and set 2 3 4 5 6 3 4 5 6. If you use A union B, so output is 1 comma 2 comma 3 comma 4 comma 5 comma 6. So this is the output, right? Union operator removes duplicates and creates only unique values, right? Union all means A union all B. So it combines both sets. It combines both sets. So including duplicates. 3 comma 4 comma 3 4 5 6. So it gives duplicates also. So RDBMS has both operations. RDBMS has both union and union all. So union is for merging two sets or two tables, but it doesn't allow duplicates. But union all allows duplicates. SQL has only union all. Union all means with including duplicates. So we have two tables, EMP1 table and EMP2 table and EMP3 table. Let's take two tables with the same order, but data is different. So columns order is same. Columns order is same. So let's take three tables. So open putty, connect to Cloudera. So let's open another terminal. So in this terminal I am creating two files. So mkdir batch 5, cd batch 5. Okay, different directory. This one is different location. So here I am creating cat greater than emp1 with this data. With this data, if you observe this one contain space is tab space. Delimiter is tab space. Okay. Control D and create emp2. So emp2 with this data. Okay, let's open our Hive and change database. So show databases. So we have different databases. Select MyDB. Use MyDB. Create a table. Create a table. Table name is emp1 and column names empno int comma ename string comma next one sal int comma gender string comma next one department number int. Row format delimited fields terminated by terminated by comma or tab space slash t. So tab space, that's it. Delimited fields, delimited, yep, row format delimited fields. We pronounce, but we did not write. Row format delimited fields terminated by tab space. So let's create one more table. Table name is emp2. Then delimited fields, row format delimited fields terminated by tab space. Let's load data local in path file is presented under slash home slash cloudera. Because file is different location, we opened Hive in different location. That's why we have to provide complete path of file. So we created batch file. No, this is local file system, Linux file system. Okay, so batch file, here we are clearly saying local in path. Okay, local in path batch file. File name is emp1 into table emp1. Load data local in path file path into table emp1. So same as emp2, file name is emp2. And observe, up to now, up to this path we already presented, right? Slash home slash cloudera. Then use this one. Hive opened in slash home slash cloudera. So up to that path, it automatically recognizes. You can use complete path. You can use complete path or continuation of our Hive started path. Because file also continuation path, right? You can use both the approaches. So first one approach I used complete path. Second one I used absolute path, relative path. Okay. So here let's see select star from emp1. Select star from emp2. So two tables. Then I want to merge two tables into another table. So before that, to store these two tables results into another table. To store these two tables into another table, we need to create one more table emp3, right? emp3 emp3 emp3. But here I am not using any delimiter because we are reading data from other tables and we are writing into this table, right? So it is not mandatory to give row format delimited fields. It is optional. So let's create this table. So if you use select star from emp3, there is no data. Then I want to store data into emp3. Insert overwrite emp3 select star from emp1 union all select star from EMP2. Is it works or not? So what we are doing, this select statement selects all the data of EMP1. Okay, this select statement selects the data of EMP2. So we got two results. Then we are merging two results into one result. Finally we are writing into where? EMP3. So let's try to execute this one and observe. This one insert override table, I think. Insert override tab, insert overwrite into na, I think overwrite into, not table, insert overwrite into EMP, right? Okay, so insert overwrite into table EMP3, then remaining for it. Whatever you are saying, I am writing. Already we discussed insert overwrite command. Let me show. Insert overwrite table. Okay, so first we return insert overwrite. Insert spelling C. Insert overwrite. Spelling is correct, right? So remaining is same. Let's use this syntax. Then observe the output. What will happen? It inserts both the tables output, or it inserts only one table output? Both table, right? So let's see whether this syntax inserts both the tables output or one table output. Because internally everything is converted into MapReduce. So let's select star from EMP3. We have both tables output, right? So this is 101, 102 is from first table, 201 and 202 is from second table. So we have both tables output, right? Both tables output. So to merge two tables, we use union all. Union all doesn't eliminate duplicates. So it combines both tables output into single tables. Let's see one more scenario while merging. If multiple tables have multiple structures, multiple tables have multiple structures. So I have a table EMP with a different structure: employee number, employee name, salary, gender, department number. Here employee number, employee name, department number, salary and gender. So column order is different. Let's take some other files. Cat EMP3. So with data, let's take data. So this is same order. Next I'm writing EMP1, EMP3. So this is EMP3. This is EMP4. EMP4. EMP4 I'm writing. In EMP4, department number 13, tab space. Department number 14, So this is 103 and this is 104, or so let's take EMP3 data and enter into EMP3 file, control D, next EMP4 with this data, with this data, control D. Let's create two tables. So create a table structure, create table, create table EMP3. EMP3 is same structure, and row format delimited fields. Row format delimited fields terminated by tab space. Yep, already we combined with table EMP3, right? Let's take EMP4. EMP4 and EMP5. EMP5 order is different. EMP5 is first department number, comma salary, int comma salary, and next gender, right? So columns order is different. Row format delimited fields terminated by T. Let's load data. Load data. So here we have EMP3 into table EMP4. Next EMP4 file into EMP4 file into EMP5 table. Okay. Now tell me how to write union null. So insert override. Insert override table 3. So insert override table 3 means it erases old data in EMP3 table and merges whatever the data we are entering. Then instead of select star, use select. This is one way. Select EMP comma, ename comma, sal comma, gender comma, department number from EMP4. Union all, select EMP comma, ename comma, sal comma, gender comma, department number from EMP5. So whatever the selected order, we can use columns in our own order, right? Whatever the order we are selecting, same order we get result. In this way we can overwrite two different tables output into another table. If columns order is different, instead of star we have to specify columns list. Okay, instead of star we use columns list. This internal generation is we are not generating this internal mappers, number of mappers, number of reducers is internally generated by Hive environment. Hive engine converts our our SQL query into MapReduce programs. So here we have number of mappers and number of reducers. It depends when it creates reducers. If there is any calculation, then only it will generate reducers. If there is no calculation, if we have only simple selector statements, it's always generates mappers. Okay, if there is any calculation is available, then only it generates reducer. So we got data, right? Two tables data. If columns order is different, then in merging we have to select column names. We cannot use star. So next scenario, we have a table 1, table 2, but table 1 has different columns, table 2 has different columns. Table has different columns. Table 1 has different columns and table has different columns. Sometimes we may get output in this way. So main drawback of RDBMS technologies is this. This is the main drawback. See, if you use RDBMS, so merging table, assume we are creating merging table. So tab 3, we are creating merging table. So tab 3 must have all these columns, right? And extra columns of this one. So in merging table, we have to define all these columns. First table has only up to this part. Second table has a department number and city. There is no designation concept. We are merging two tables into this table. So first table outputs stores in employee number, employee name, salary, gender, department number, designation. Second table output stores in employee number, employee name, sal, gender, department number and city. So this column is memory is reserved, but data is not available for second table. But first table, this column data is available, but this column data is not available. If we create a common column, all columns of two tables, when we store first table data, this one stores value, this one completely null value, right? This one is null value. If you store second table data, these column values are null. Then in RDBMS, whether you store null or not, internally it reserves memory. Assume column, this is varchar and you designed varchar of 20. It reserves 20 memory space. City you define 20. So first table values assume 1000 rows are there. 1000 rows with the designation column is available, but the city column 1000 rows empty. Means 1000 into assume 1000 into 20. 20,000 memory spaces are reserved but not used. So to resolve this one, if you go for NoSQL, NoSQL is best solution. NoSQL, there is no schema, dynamic schema. RDBMS, first we will create schema because table 3 We are creating schema first. Because of creating schema, whether you store values or not, each row it will allocate memory. But no SQL, based on the values you are storing, it will create schema. So dynamic schema. So for every row, based on the columns values, it will allocate memory. So it reduces lot of memory spaces. This is dynamic schema. We'll discuss this one in Monday class. This is static schema. We also call this is schemaless, schemaless, but schema is mandate here. Schema is mandate. So without creating schema, we cannot insert data into table. So while selecting data from different schema structure, first we need to create a tab with this three. So what I am saying, in merging table, in merging table, in merging table, we have to create columns of two tables. So in this way. So let's take some records of table 1, tab 1. So I'm taking 101 comma separation. I'm taking, or take tab space. We can reuse tab space, tab space, tab space, tab space, and department number. Next 102 tab space, 103 tab space. Next tab 2. Oh, uh, salary, gender, department number, and designation, right? Tab space, designation. Next here tab space. Next tab 2. Employee number 103 tab space, tab space, salary, tab space, department number, tab space, city. Next enter one more record, 104 tab space, tab space, 50,000. Next department number 14, location is Bangalore. So we have two tables, structure is different, schema is different. Two tables, schema is different. Okay. So let's create a table files. cat greater than tab 1 with this data. Control D. Tab cat greater than tab 2 with this data. Okay, two tables are there. Next one, insert this data into, first let's create tables, right? Create table, tab 1, create table, tab 1, employee number, employee name, department number, salary, gender, no. So tell me the order, employee number, employee name, so salary, gender, department number, gender, department number and designation, department number and designation, designation string. Next, row format delimited fields, row format delimited fields terminated by tab space. So the people who knows SQL, they will enjoy not like anything with HIVE, right? Because HIVE is similar to SQL only. There is no difference. Almost syntax is same. So they cannot feel any difficulty. This is English statement, right? But everyone understand easily. That's what I am saying. So no need to write any programming, no need to apply any programming skill. Yes or no? So who knows already SQL, they can easily work on HIVE. So let's see, we created two files, right? And we are creating uh, table tab 1. Okay, let's create a table tab 2. Tab 2 contain employee number, employee name, gender, no gender, right? Employee number, employee name, salary, department number, no gender, department number plus city, no designation city, and row format delimited fields terminated by tab space. Okay, let's load data. So tab 1 into table tab 1, load data tab 2 file into tab 2. Okay, create a table, create a table. So here we are using designation string comma city. So table name is tab 3 and gender also available, gender comma string. Yep, gender string. Okay, we have these columns. So here we don't require row format delimited fields because we are merging two tables data into this table. Tell me the query to merge that previous tables, two tables data into this one. So we use insert overwrite is common, right? insert overwrite into tab 3. There is no union command. We have only union all. Because here first why they removed union means union eliminates duplicates, but big data requires complete data. On that data, whatever part we want, we use processing logic. First we need complete data. Insert overwrite. Next tell me the query. Select star. So I want to select a table. Star from tab 1. Why group by? Okay. Union all. Second, oh, select star city ఒకటి చాలు. City from, if you select, it will return only one column. Remaining columns values it will not return. Whatever the list we provided, it will return only that column values. So remaining all columns you will see null values. Select star from tab 2. Try. So it clearly saying semantic exception, schema of both sides of union should match, but here not matched. So we are not checking conditions. So we want to merge both the tables data into single table, but both tables syntax is different. Hmm? See, someone I think said. So we have to use individual columns. Tell me how to use. You are almost correct, but tell me the syntax. Yep, tell me, I will write. Select employee number, employee name, salary, gender, department number, designation, from table 1, union all. Select employee number, employee name, EMPNO, right? EMPNO, comma, E name, salary, D number, city, from table 2. So what is the difference between previous query and this query? So if you use star, it is giving same order, but if you specify columns also, it is giving same order. Press enter and observe. So clearly saying semantic exception schema of both sides of union should match. No, you are almost reaching, but only small difference. So first one, observe. Let's see. Uh, describe tab 3. So finally our target is store data into tab 3, right? Yes or no? Merging tab 1, tab 2 into tab 3. This is our main target. Tab 3 column order is this one. Yes or no? This is the tab 3 columns order. So first insert overwrite tab 3. So select first query whatever you are saying. I'm writing. I'm checking whether this contain above order or not. Employee number, correct. Employee name, employee name, salary, gender, department number, designation, right? City is missing. In city location, add null or some empty value. Empty value. Take empty value. Either null or empty value. Union all. Union all. I am selecting from this one, right? Select table to employee number, employee name, salary, but gender we don't have. So let's add a null. Department number, designation is not available. Let's use null, comma, city is available from tab 2. Still we got error. What is the, see, it's saying schema of both sides of union should match. So subquery does not have the field gender. So in that case, what we did? So we stored null values, right? Table 2 lo ledu. Yep. But in that case, what we can do? So here if you pass comma null, is it correct? So it's searching some other value in list of columns. LST. Yep, here whatever the columns we are listing, it will expect from this table. Whatever the columns we are listing, order we are listing here, right? Same order it will expect from this one. Yep, we can insert null values. We did not specify any condition to column, right? For column, HIVE it allows any value. Let's change, instead of null you can use double quotes, string. See, select, here we are using just order, single quote. Yep. As city. So this is extra column result value. Result we are generating. Next, as gender, as designation, and that's it, right? We taken only design. Yep. Okay. Let's take unional as gender, as designation. But if you go for no SQL, no SQL, row to row may have different columns. In no SQL, row to row may have different columns. may have different columns, but in all rows we have to take same columns, whether column may have value or not. In RDBMS, all columns, all rows must have same columns, but value may have, may not have. It depends upon the insertion. All rows must have same columns, but here NoSQL advantage is row to row may have different columns. One row have less columns, one row have more columns. Example, let's take one employee. One employee has phone number and office number. Another employee has only phone number. Another employee has phone number, office number, and LAN number. One employee has Gmail account, Yahoo account, Rediff account. Some people has only Gmail account. So like that, based on the values, based on the insertion, row to row columns are different. That's why we are saying this is dynamic schema. This is static, fixed schema. Not only static, we say fixed schema. We cannot change. Once we define, we can alter, we can remove or we can add new columns, but fixed. But fixed. So before inserting only, we must have schema. But here it is optional. Schema-less. Most of the NoSQL databases are schema-less. Yes. No, no. Dynamically. Dynamic. That's what dynamic schema. Bigger headache part of RDBMS is joins. NoSQL advantage is avoid joins. This is main important 5-star point. No, most of the times we cannot use joins. Avoiding joins is main important feature of NoSQL. So if you want to retrieve data from multiple tables, we have to use joins in RDBMS or SQL. So joins are mandatory. If you want to retrieve data from multiple tables, joins are mandatory. But in NoSQL, joins are optional. Not optional, 99% avoiding joins. So how to avoid joins and why joins are required? We will discuss joins, why joins are required in our joins concept. Why, how we are avoiding joins, we will discuss in Monday class. NoSQL part we will discuss why joins, why, how we avoid joins in NoSQL. What is the advantage of avoiding joins? What is the advantage of joins? What is the advantage of joins? And what is the disadvantage of joins? Why NoSQL removed joins? If you remove joins, what will happen? So joins, why RDBMS introduced joins? There is some advantage, right? Some advantage they introduce joins. Some disadvantages they introduce, they avoid joins. If you avoid joins, again we lose this benefit, right? Here benefit, here are disadvantage. Here avoiding joins is benefit, but without joins we have disadvantage here. But how NoSQL solves that disadvantage is the concept of NoSQL. Because RDBMS problems are NoSQL avoids all RDBMS problems. Simply we say NoSQLs are alternative to RDBMS. NoSQL databases are alternative to RDBMS.